The idea is to bring this group of social scientists here and to try and work out whether the robots actually, in the way they interact within the arena, actually can teach us something for social science.
Frances and her student Sajida are both partners in the Artificial Culture Project, and it's Frances that asked if we could host the meeting today, which I'm delighted to do.
It's quite an interdisciplinary group that we've got. Just like the Robot Culture Project, so hopefully we'll get a new take on things.
Well, I'm here today because I'm part of the mimesis project, which is about the spread of behaviours, particularly health behaviours.
Normally we're focusing on human beings, but this is kind of a very sort of interesting extension, since there's a sense in which you're trying to figure out how robots imitate each other for purposes of producing culture.
We're effectively building a very abstract model that we hope might illuminate the processes and mechanisms by which ideas or actions or behaviours propagate. So these robots are allowing us to study embodied imitation. Like animals, they're having to see with their own physical senses. They're having to figure out how to translate what they see into how they behave in order to imitate what they see. And we have this system with the glowing red cameras up in the gantry to track the robots. The evolutionary process relies on having just enough variation. And we want imperfect imitation because we're interested in how behaviours change and quite literally evolve. And you get less than perfect fidelity imitation for free. So initially, this one is watching and this one is enacting. It has no choice but to do a triangle, because that's all it knows about. Number 12 will try and figure out what it is. And once it's tried to figure out what it is, it'll add it to its memory. But what number 12 will then do is it'll throw a dice to decide which of the two things it now has in its memory to enact. This guy will then copy whatever that thing enacted. And what we do is that we keep adding. So there are obviously millions of selection strategies that all to some extent require you to make a judgment. Now, a strategy that doesn't require a robot to make a judgment is an interesting one to explore. You can see that the number 9 is now doing its triangle. Now, as soon as it's stopped, it'll signal that it's finished. That guy has now signaled that it's going to make a meme, and that one's turning and has looked for and now found the other guy. So you can see that they've reversed roles. We can almost think of this as a new species, but it has the huge advantage that we built it and we can control it. Now, I think they've lost synchronization here. I think I'm going to stop this and just reset them. These experiments never work as well when there's a crowd of people. And that's not the Blue Peter effect, it's quite literally the clothes and colours and everything. Yep. So that's rather a good copy of that previously rather bad copy. Look at these repeated figure of 8s. So in other words, if one of them copies rather badly, that gives rise to this figure that's a long way from a triangle, it's got more sides to it, then the other robot copies that rather well, then you can see how you get this dominance.
There are certain things that could be done on computer simulations, it seems quite easily. I mean, right, whereas I think with this stuff, this business of the embodiment and the way in which errors are constitutive of new patterns, I think that's the thing to focus on that's unique about this way of studying stuff.
Well, the interesting thing was, it seems to me, the way in which these robots can in fact develop new forms of knowledge and experience that go beyond just what they were programmed to do, so that their learning actually does have feedback, that does create new patterns and does present kind of emergent properties of knowledge that wasn't there originally.
What they're trying to do, it seems, is to get this balance around the sensitivities of these devices, where things can build and create.
It's interesting to note the differences. They don't mimic each other exactly. There's always some kind of slight difference.
As a sociologist, I think it's interesting to see how different disciplines interact. I mean, the people we've got round as sociologists, medics, robotics, and it's a kind of accumulation in a kind of a mixing of knowledge.
So I'm very interested in the mathematics that goes behind describing a social system. The way that you actually set up something which has got some kind of reaction to its environment or to each other, described mathematically, isn't necessarily confined to describing robots. It could then be generalised or adapted.
After lunch I'm looking forward to perhaps a bit more discussion about how we might apply that to society.
Where I have a problem is understanding what value this might have when you then abstract back from robot world to human society.
How could you tell what introduced meme set or behaviours was disruptive?
One can only determine disruptiveness retrospectively. So one might introduce a behaviour that is different, but one doesn't know whether it's going to be disruptive until it plays out, because it may actually be producing something cohesive. Or
for me, a hugely interesting experiment for this project would be to have a population of robots that is free runs until it becomes stable. Then you intervene to create some physical separation. The emergence of multiple traditions would be very interesting.
For that particular example, what is the added value character of the embodiment?
Firstly, the end result of this experiment is, or any of these experiments, is completely unpredictable. And secondly, we can then backtrack and, as it were, construct a natural history, to put it that way, of how this population got from where it was there to where it is now.
There are some practical problems with that, aren't there? In the sense that if you've let your robots run and you've got two subcultures, there might be a norm for each.
You're engineering emergence, at the edge of complexity, at the edge of chaos, sort of thing, complexity at the edge of chaos, sort of thing. And then you're also staging resilience at the same time. But the advantage in your way of staging resilience is that it really is real resilience, in the same way that a human society would have to have resilience.
It looks just right from the standpoint of talking about, especially making interesting comparisons between people and animals and robots, that there is a sense in which the embodiments make a big difference to how imitation occurs and how learning occurs and all the rest of it. It's quite obvious that there's a basic truth to that isn't captured by computer simulation. And emergence has a lot to do with it.
What we're trying to do is to navigate ourselves into that relatively small region of that large design space where stuff unexpected happens. It's this fine line between programming just enough to have interesting and useful outcomes, but not so much that it becomes perfectly obvious what's going to happen when you run this thing.
that was fascinating.
Yes.
Thank you.
Thank you very much.
Well, thank you.
Really good. Well, the big thing was that the social scientists think that we're on the right track, in the sense that there really is something here that we could use.
I think one of the outcomes is it sets in train a whole lot of themes, and for me, the major theme it sets in train is free. What do you get for free?
I think it would break some real boundaries, especially within the social sciences, where at the moment there's hardly any engagement at all with robotics stuff, let alone embodiment studies concerning robotics. So I think this could be quite trailblazing within the social sciences.